Okay, part 7, typecasting. So we've been going through the data types of the Python language, um, and recall what is a type. A type is a uh, data in memory, usually data that is structured in a certain way. In the case of an int, it is a series of bits. In the case of a float, it's a series of bits in the IEEE floating point standard format. Um, if it's a string, it is a series of characters in memory. Um, and data types are also behavior, so they are code associated with that particular kind of data. Um, so in Python we have Python is a dynamic language. So in some languages, to declare a variable and store a type in it, you have to also tell the language what type that variable is going to hold and will ever hold. Like it cannot then hold another kind of type. Well, in Python, it is dynamically typed. That means variables can be declared and you can put anything in them, even a data type that it did not originally store. So you could start out with a variable and it could be holding an int, and then you could change that to holding a float. In Python, I mean, this introduces a challenge. Like sometimes we might be working on a piece of the code that gets data from somewhere else and it doesn't even know what that data is. So Python has a few ways to help us figure that out. One of them is this type function. Like if you click this link and go, it'll go to the Python standard docs, and um, you can read through this if you want. But let's pop back here. Okay. Let's jump into the code. Oh, what's that about? Oh, it's because I'm on the server where this is. Terminal, new terminal. Okay. 2 lesson, and we are in typecasting. Okay, so let me go ahead and trace module 2. All right, so we're at this line. Recall we stored my int way back when in our integer lesson. It should still hold an integer, and it does. So if we do type my int, we get this weird thing. It says class int here. We'll get into classes and what they are in a later module, but for now, just when you see class, understand that this means essentially it means data type. So my int is holding an int, and so int, the keyword int, is a built-in keyword in the language, and it is the type, the data type int. So if I just said int, you can see that these are the same. So when we do run this assert statement, this comes out as true. Int is int. Same with float. Booleans are just bool, and strings are str, short for string. Everything in Python has a type. That includes functions. So let's go ahead and jump down to line 23. So we've defined this function. If we did type this function, we'll see that it is of class function. None also has a type. It's class none type. And again, is cropping up here, and we'll talk about the difference between is and logical equality soon when we talk about immutability in memory. But when you're comparing two types like int together, you can use is. Okay. The other thing to know about data types in Python is that some of them can be coerced to other types. So like the most frequent sort of type coercion that happens in Python is converting an integer to a floating point number and vice versa. Like you might imagine, and you can do this explicitly by using the name of the type as a function. So 6.1 is a floating point type, right? It's got a fraction. If we wanted to convert this to an integer, well, let me get rid of this type part. We could do so just by passing it to int as a function, and that'll just remove this fractional component from it, and then we just have the whole number 6. Conversely, we can convert an integer to a float. You see, added a fractional component of 0. The other coercion that you can always be guaranteed that you can do in Python, you can convert anything in Python to a string. This is pretty helpful when our programs have to generate a lot of output to let users know what they're doing. Not every data type that is defined either by the language or by just users who have built their own custom types has sort of a logical way to convert it to a string, but nonetheless the language will guarantee you that it will spit out some kind of representation of anything you try to convert to a string. Sometimes that just might be telling you the data type that it is and nothing about the data that it holds. But everything in Python can be converted to a string. So if we convert a number, we can see that it is now a string because it has these quotes around it, and we'll talk about strings in more depth in part 10. But we can convert our Boolean values to strings. When we convert string, when we convert none, we get none. And again, the types, right? So the type, the data type of a piece of data is also itself a data type, and we can convert types to strings too, and that's what we were seeing before, where we get this sort of representation that's telling it's a class, none type. Okay. Let's go ahead and jump down to line 63. So sometimes types are implicitly coerced, and the most common place this happens is when we're doing arithmetic on integers. And consider when we divide 4 by 3, the result of this is not representable as a whole number. And so to do this operation, the result has to be coerced to a floating point number. And you'll see that Python does that automatically for us. Now, if you recall, if you went through all of the operators that integer had, there is one on there called integer division, which is the double slash, and this will not coerce the result to a float. It'll stay it as a whole number, which is equivalent to saying something like this. When the other time an integer is coerced to a float is if you do any operation between an integer and a floating point number. So if I had 3.0, which is a float, and I added it to 4, which is an integer, or let's just show that, let's just give it a fraction so we can see. Or if I multiply it, but if I did this, it remains an integer. So just be aware that that's happening, and it's kind of correct, right? It just kind of does what you think it's going to do, and you don't really have to think too hard about it. So this is also what's happening when we use variables in if statements or in logical expressions. Anytime we use a variable in a logical expression, it is going to try to implicitly coerce that variable to a Boolean data type, so either true or false. And this is the other coercion that will always work in Python. You can convert anything to a Boolean, even a type. And let's just say, what happens when we convert the none type to a Boolean? It doesn't really, oops. It's just bool. And the rule of thumb for coercing variables to bool, unless they have some sort of like special obvious meaning, like an integer number 0 converted to a true false value is going to be false. That just kind of makes sense. If it doesn't make sense, it is always going to be true if it holds anything. So none, of course, is false. But you know, if we hold any other kind of data that is not none, or does not have some sort of special rule about how it is coerced to a Boolean, if it holds anything, it's just going to be true. So before, when we were looking at statements like this, where we're adding an integer to a logical expression, it's roughly equivalent to doing this. Like the not operator, when it operates on my int, it's going to implicitly coerce that to a Boolean. Okay, there's some more gateway exercises, so go ahead and do those, and then afterwards proceed with lists.